All right, awesome. Looks like we're live. So, hello everyone. Thank you for joining us in our weekly Swift chat or introduction to Swift stream. I'm joined by Sarah, of course, as always. She's in the Discord, so you might not hear her. I'm on my headphones. But feel free to join the Discord and join in on the conversation or post your questions in Discord if you have any questions while I stream, or post them in the chat in YouTube. So for today's stream, we're going to be going over an introduction to Vapor, or a framework in Swift that is meant for the web, hosting a website, or maybe an API. But we're going to work on that a bit and get a nice introduction. And I'll just kind of explain to you what's given with Vapor when you create a project. But for a first command, this is mainly going to be for Mac OS. There's a little different stuff you have to do for Linux. But for Mac OS, you can type in brew, install, and Vapor. And hopefully you have brew if you have Xcode, the command line tools. But brew's a package manager for Xcode, so that will just install Vapor in your command line tools. So let me know when you've done that, Sarah. That'll give me a good estimate of like how long it's taken. I already have it installed. Oh, so you're gonna want to run brew install Vapor. And so I think you should if you have Xcode. And I just put it in the streaming discussion channel. Let me know if that doesn't work, because that'll let me know. I've had brew for too long to remember if it's default or not with the Xcode command line tools. Oh, yeah, it's called homebrew, but the command is called brew. Oh. Yep, I'm okay. I just remembered. I'm adding it into the chat and the Discord to let you guys install that. Awesome. So once you get that and you get Vapor, that will take a bit, and I'll try to go slow. We're just going to go create a folder, the brew.sh in the YouTube chat. Huh. Weird. So probably. So we can go into some folder and we're already in there. And once you have the command Vapor installed, you can just type in Vapor new and then your project name. So we'll just do Swift stream Vapor example for just a long name. And so that will clone a template. And what that will do is just create a directory that we can go into. And that will have the basics of what make a Vapor website or a Vapor app. So after we've created a Vapor app or a website or anything like that, or a Vapor project, or even if we're going into a Vapor project, what we do is we want to type in Vapor build, because we don't see a .build folder. We need to actually build all of our dependencies and actually build our project. So if we type in Vapor build, it'll say that we have no build folder, and it's going to fetch our dependencies, build the project, and then we'll be able to run Vapor run, and that will actually put the website up or run it locally. So, yeah. Yep. So Sarah asked if I can just have kind of a history of, does my history show correctly what I want? So I guess I'll just put in the what to actually do while we wait for this, because this will take a bit. I have what I'd call a okay fast computer, but building all of the dependencies, there's quite a bit of them, and I'll show you when we get in Xcode how many dependencies we're actually using for Vapor. But I'm just going to say my list of commands. We did brew. That's a big command. So that's like the worst to have. But then I think we did brew install Vapor. Alright, so that's what we've done so far, and I'll try to make this bigger. And of course you won't see this URL, but remember this first thing is just installing brew or homebrew. Oh no! Oh, I accidentally closed it. That's my bad. I'm so sorry. Let me get that up. For some reason, oh, my computer's going slow. You can see the graphs up here. It's like fully loaded. And that's why I told you that this will kind of run it. Yeah, I'm just not going to have the... sorry, I'm not going to do that. It's going to just be too laggy right now. Sadly, we have to wait for it. I should have had a pre-built project, but I'd like to give you an understanding of how long it may take to build a project. But here we go. We got it. And once you build it, then you're good because you've built most of your dependencies. That's why it takes so long, is because we have to build all of our dependencies. Not because our code takes that long. It's just the dependencies. So after that, we can type in Vapor run, and it's going to run our example, and we can check it out at the local host right here, and it works. There we go. So it says it works. Awesome. So we've actually connected, we've seen it, we've hit our server in just what the template gives us. Oh no, Arcus is asking about the slight delay on the wallpaper animation. This is actually 10,000 different randomly generated colors, and they change colors every 5 seconds. Sorry if that drives you insane. So that's the quick example of starting a new Vapor API or website, Vapor project, building, and then running it. So I'll wait a bit for Sarah to catch up, because that took me that long to do. So I assume that anyone following this live would be a little bit behind, because I don't know, maybe some... Yeah, yep. Sarah says, yep, she is behind. So fine. We'll just kind of check out the... Whoops, sorry for all these. So the folders and files that were given into the... Oh, yeah. Arcus says lag. Yeah. There's probably quite a bit of lag while I was building that, just because that was using like too much of my CPU. But yeah. So for what's given in the very beginning is contributing. That's just default. Get ignore, all this stuff. We have the packages that we use, or that it has dependencies on. So if we check out those packages, we can see how many that I was saying it depends on. And it only depends on 2. Oh, that's not that bad, right? But Vapor depends on quite a bit, and SQLite or Fluent SQLite depends on a handful as well. So You'll see when we create the Xcode project what I mean and how many dependencies we're actually using. But other than that, we have the public folder, which will be more of our HTML files, CSS, JavaScript, or maybe even, I think, our Leaf templating files. We have a README. Our sources are where most of our code is for our backend. All of our controllers or our routes of where you can go on the website and what they actually do or what they return. So we'll be mainly in the sources for today. But we also have tests, and that's if you want to write any unit tests for your code, and also highly recommended. But we're not going to focus on that today just because we'll just have, of course, an introduction to Vapor. We have some other files that we don't really need to worry about. How are you doing on that, Sarah? Can I keep going on, or still building? Yeah, so the fetch may take a while, and that's what she's saying she's stuck on, so yeah. We're gonna go on. Sorry to leave you in the dust. But what we can do now is we can type in Swift package generate Xcode project or Xcode proj, and what that will do is it will create our Xcode project file because we don't have one. So what you'd have to do is you'd have to edit all these files in a text editor instead of using Xcode. But any Swift package can simply generate an Xcode project. So you can run Swift packages on Linux and you don't use the Xcode project, or if you have it on Mac and you pull it, you can generate this really quick. So now we're just going to open Swift Stream Vapor example Xcode proj or Xcode project, and so let's get this up. Okay. So we're looking at the README right now, but you can see how many dependencies we have, and there's quite a bit. So that's why it took that long, because it was compiling all of these. Computer's going ham while I index really quick. So, oh, thank you, Arcus. You can also run Vapor Xcode -y, as he said in chat, and I'll show that on the stream really quick. Yep, you can run this too. Just touching on the one last thing, I guess why I'm used to the Swift package generate is because I use Linux for quite a bit of my Swift, and for that we don't have access to the Vapor, or at least, okay, so yes, you have access to Vapor and Vapor command line on Linux, but for my setup, I'm on a very up-to-date Ubuntu, and I guess officially Swift doesn't support my Ubuntu, but I can get it to run, I can get Vapor to run, but they just throw an error that they don't support my version of Ubuntu. So for me, I've gotten used to just using the Swift package manager commands, Swift build and Swift run, and Swift generate package manager, because those do the exact same as Vapor, or at least that's what I use on Linux. Oh, terminal just went away. So looking into this, we have the sources, and that's what mainly we're going to look at. There's the run, which just contains the main Swift file. Not too much in there. And I'd like to note that this is Vapor 3 as we're going into this. There's Vapor 4 just being released, like now and upcoming or in the future. There's more releases coming out. It's not fully released. But yeah, this is for Vapor 3. I will be looking into Vapor 4 and most likely putting out some videos for Vapor 4 when I'm more familiar with it. But yeah, Vapor 3. And right now we're just building. We have some errors because we need to index and compile everything. So give me a second while my computer goes ham on this. Jeez. Let me share the Vapor docs really quick too, if anyone wants to follow along there. So, in the chat, there's the intro to installing on Mac OS. That's kind of the beginning of the docs for Vapor. So pretty much you can follow through that, and most of the things that I'm talking about will be in the docs. I'll just kind of give you a walkthrough of it, explaining what I understand from it and working with it for a bit. And also giving a little bit of an example of using this. Okay, so we've indexed, and we're indexing. It looks like the errors have gone away. So let's check out some of the code that we have. Let me make this bigger. Okay, cool. So not much happens in the main Swift file. It just kind of runs the app. So first off, we'll check out, I guess, the app. Oh, what's up, Sarah? Sorry. Oh, for accessing what? So Sarah's stuck. Have you run the? Are you trying to run? Have you run the Vapor project? Oh, okay. So now, once you see localhost after Vapor run, you're actually running the project. So if you command click on localhost, or if you go to your web browser and type in localhost :3030, I think, or 8080, then you should see it. Yep. So your console will stop letting you type stuff, and all you have to do is you have to do Control-C. Other than that, when you're using Xcode, you can just run and kill it normally, but you have to just press Control-C to kill that command. So going back to the project, the app, we don't really use that much, or don't really touch that much, and I'd say boot, don't really do that much, at least for introduction. Mainly our code for this kind of root level of the app is in configure, where we configure our services that we use, our database, migrations, and everything else. And I'm going to go through here really quick, kind of explaining everything lightly. If you need a further kind of definition of what something is, feel free to ask. But this is meant to be kind of more boilerplate. This is what's given to you, and optionally, yes, you can change it. But what I will try to explain is what this is, and potentially what you can change it to. So we're thrown into the first little example, and we have a service that we're trying to register. So this first service is a Fluent SQLite provider, which really just is a database provider, and Fluent is a layer over some database that lets us interact with it. So using Fluent SQLite provider, we can interact with a SQLite database using Fluent. We can also potentially use I guess I'll just type it in instead of, I have to import it. So I'll just so another one that we could use would be Fluent post. Whoops, maybe I'm pressing it wrong. Great. So we could use PostgreSQL or PostgreSQL. I don't know how you say it. But yeah, we're using SQLite. You can use MySQL. So there's a few different providers that you can use. But simply, we're just going to use SQLite and It's just a layer of Fluent for it. So we'll see that later when we actually save something to a database and retrieve it in our app or get it through the API. So for this router, this is just registering a default router. I mean, like I said, it's boilerplate, so a lot of this is kind of required here unless you make small edits to it. But you can see that we have the routes folder right here that I'll go into next of where you can go in the app or the website. If you go to a website, you can normally type in slashes. So if we went to localhost 8080, a route could be, hello world or hello, and that would be under the routes. So we have some middleware, and I'm not going to touch too long on that. Oh, see ya, Arcus. Have a nice night. For the middleware, it's kind of, I hate to say it, but think of it as just a black box that kind of handles stuff. We really want to deal with the back end and the front end. And middleware is services that handle like redirects. One example right here is a middleware that serves files from the public, one that catches errors. Another one might be, like I said, a 404 middleware, where it automatically gives the user a 404 if they don't go to the correct route. And this is something that Vapor does. So that's just our middlewares. Don't really have to worry about that too much. But here's where we actually create our SQLite database. And we're going to say we're going to store it in memory. So every time we kill the server, it will kill the database. And every time we run the server, it'll create a new one. And then we just add our database as SQLite. And we say that we want to configure a migration. And migration in Vapor is I'm trying to think of best how to explain it. Pretty much in the most simple way, ToDo is a SQLite model. You can think of that. It's able to be written as SQLite, and so that's what we say is we have a migration where we add the ToDo model, and we say that it can be put into an SQLite database. The migration just means that if we add variables or remove variables from the object, the table will update accordingly. So that's kind of the magic. We don't have to deal with SQL. We just deal with the object, and the table updates everything for us. So that's a nice part about Fluent. But then there's also caveats to that. I mean, we're dependent to however Fluent manages SQL, and maybe that's inefficient. So those are just some things to think about. But right now we're going to use Fluent, and we'll check out some basic SQL or Fluent SQLite. Really, you'll just be seeing Fluent, because that's the whole idea, is that if I write Fluent, I just have to change what I want to write to. Fluent SQLite, Fluent MySQL, or Fluent PostgreSQL. But ideally, the code should be the same. The database is not, and how it's handled is not. So for the routes, we have a few different routes. We have basic route that we saw, or root, or just localhost 8080. This is the route, or I guess I'm trying to think of other words. Just like a slash or root, like I said before. And so we can hit optionally the hello world route because it's set up. It's set up as a get, so we can quickly go to it. So let's see that. So go localhost and waiting. Yeah, waiting for it to run. There we go. Too fast. And if we type in hello, then it'll say hello world. So we've hit a route, and it returns some string. So what about if the string isn't exciting enough? Oops. Well, let's make it an H1 then. Oops, I can't type. So now if we rerun it and wait for this to tell us, then I can do this, and it sends us this, but it just sends a string. So it's not giving us HTML, it's giving us actual just a string. Okay, so I want to make that clarification of this isn't any HTML, it's just data coming back from the server. Okay, so we're actually just getting a string. So for then example of configuring a controller, we have some to-dos. So I could go to to-dos, and this won't actually give me anything. This gives me an empty array because we haven't actually added any to-dos. So let's see how we might add one. And I'm going to use PA, but feel free to use Postman, or if you're brave and know what you're doing, I would use curl. But let's check that out. Get rid of all this extra auth that I have, since we don't need it. So I guess I can use that. So we're gonna do localhost, the port, and then what we'll do is we'll do to-dos, and let's check what route it is. Okay, so we're gonna click back here and we'll see, yep, it is to-dos, and all it is a post. Okay, so if I just do this simple get right here, we get this array again. Okay, so we got the same thing. So ideally, going to the web browser at to-dos is the same thing of just getting or doing a get request on to-dos. Okay, so before we actually create some to-dos, let's look at the to-do controller. Okay, well, that's simple. We only have 3 functions. We have one that returns a list of all the to-dos, and that just does to-do, and it does a request or a query on the request, which to be async, we're really going to use request a lot. We're going to pass that around and do actions on the request. So you'll see that a lot in Vapor, and I'll touch on that more. Like future and async, a big topic on its own, and I think another stream would be more suited for this, solely focused on that. But you can just kind of think of it as right now, I press enter, I get a request. The server may get multiple requests at the same time, so async is just a way to deal with multiple requests at the same time. Just think of it basically as that. And I'll touch on it a little bit more. If you have any questions specifically, I'd love to address them. Just to make sure that anyone doesn't hear that and just takes away some misinformation, is that async and sync, or asynchronous and synchronous code, are 2 different ways on how to handle code. Synchronous code is line by line. So if I had 3 lines, line 1, line 2, line 3. Synchronous code pretty much means that line 1 needs to complete so that we can move on to line 2, and then line 2 needs to complete so we can move on to line 3. Asynchronous code means that line 1 may fire, line 2 may fire, and maybe line 2 does something and it goes into a background thread. It fetches the weather or anything like that, and at some point, or we don't know when the call might finish. So this is where it does some stuff in a background thread, and that's asynchronous. It will run 2, but right after we run 2, we run 3. We don't wait for the response to come back. In a synchronous style, you'd wait for the response to come back before you do anything. But Vapor is async or asynchronous, so we can take in multiple requests and not wait for every single step of the way. So we do to-do, we query, and we say, hey, I just want all of the to-dos in the database. And what is to-do? Simply right now, it's just a title. So it simply has a title of what to do. For this, we can see it's an SQLite model, and the database is an SQLite database, and the ID is kind of given to it by the database, so that's why it's optional. We extend some other things down here, but this pretty much means that it can be used as a dynamic migration. The table will be managed for us. Content, we can send it over an API call, or if a phone calls from our API and wants the to-do list, that we can send this over HTTP. Parameter lets us just identify these from their ID through, if I wanted to get a to-do, I could do a to-do with an ID of 3, and I do to-do/3, and it's able to get the to-do with an ID of 3 because of parameter. And that's because ID is an int. So that's our model, and that's our controller. So that's really all. And looking at the controller, we just have an index that gets all of the to-dos. We have one that creates it, or we give this function our request, and it tries to decode a to-do. And if we given it a correct to-do object, then it will save it to the database. Same thing for here. If we want to delete a to-do, if I created a to-do and I say I want to delete number 2, then this is looking for a to-do with ID number 2, and it will delete it from the database. Okay. I'm going to wait for the stream to catch up a little bit and for me to catch my breath. Do you have any questions, Sarah, or does anyone watching have any questions right now? That was really just a quick dive into it, and like we've touched on most of the things that this template project comes with. So okay, so if there's no questions, then I'll just go on to the next one, and we're going to do a request, but this time we're going to do a post request. Okay. And what kind of post request are we going to do? Well, it's going to be localhost, and it's going to be to-dos, and I think that's all we need. We just need actually stuff in the body and create, or whatever we're calling this route and the function that this uses. It's expecting a to-do. So let's just create a to-do in JSON. Okay. So really, it's not that complicated because it's just a string. So all we have to do is create some JSON and say it has a title, and we'll say some title. Okay. All right. So now if I press enter and send the request, it says 200 OK. So that just means that create actually saved it, and saved returned 200 OK, and we've actually saved it in the database. Okay. So how do we actually check that? How do you know I'm not lying? Well, we can check it on either one of PA, curl, or Postman by doing a GET request, and we'll get it. Or we can do the same thing and just do the to-dos route, and we'll get that. Okay. So let's add one more, and let's say delete this, and we're gonna add another one, and we'll check, and we have another one in the database, and this one says delete this title. Well, let's say I messed up and I don't want that one. So what I'm going to do is to-do/2 in Safari or whatever web browser you're using, and this won't work because we're doing a GET request in the browser. So to actually delete this, we'll go, and I'm going to create a new request. We're just going to make sure we do a delete request specifically. Localhost, to-dos, and then we'll just pass in the ID that we want to delete. And for mine, this is 2. So we're going to delete. We get a 200 OK. And that's because in this delete, we actually transform this request into a 200 OK. And now we see that it's been deleted from the database. We didn't have to deal with SQL at all. We didn't have to deal with setting up a table, creating the database, any of that. This has all been managed for us. Okay. Taking a pause right there. Do you have any questions, Sarah, on kind of what we're given right now or anything that happened? Or does anyone in stream have any questions? Oh, no problem. We can go into a quick example of, let's say that we wanted to add a description to our to-dos, okay? So we go into into to-do, and let's say we add some, oops, not vase, some notes. And we'll just say it's a string, and we'll have to add it into the constructor. So we can say notes, string, and we'll just say that there we go. Okay. So we've done that. And so sadly, we can't really tell. Because what I said before is that this is actually in memory. So when I stop running this, this will delete this and won't do the correct migration. But let's see. I'll show that at another time. But just realize that this is not doing a migration right now, but it will set up the SQLite database to have a table with to-dos, and that will contain title and notes with an ID. So that what I'm going to run now is different than what was before, and the databases are somewhat different. So if I do get, or if I run here, we won't see anything. Okay, don't see anything. And now if I do a post and the same exact stuff without changing description, I don't think we're going to get a 200. And we get a 400 bad request, and it says value required for keyed notes. Okay. Well, I don't want every to-do to have, notes. So let's make that optional. And all we have to do is just make it optional for the constructor, and we're good. So let's run it again. Wait for it to build. And if I get the to-dos, we don't have any. That's good. That's expected. But now let me try to create a new title. So we got new title, and it says 200 OK. Oh, taking a little bit. There we go, and we can see it in the browser. We created it, and we don't need notes. But now that means I can optionally add notes and say something here. And so now if I create this one with notes, it gives me another 200 OK, so that's good. And if we run to-dos, now we have our first one has just a title, and our second one has a title, and it has a notes. So that's how quickly we can change stuff. We don't have to deal with the actual database. Vapor is really nice and handles this for us. So it's a no SQL database model. Really nice, but it has its caveats, and I'm not trying to say that SQL is bad to write and you shouldn't. I think it's I think you should know both, and once you've had experience with both, then you can pick the drawbacks for both. But definitely get experience with both. But this is tough to get experience with when it's just like, hey, it works. You don't actually understand what's happening in the back. So we have this. We have that putting up some to do. So I can add more. I can delete, or I can get all of them. Okay, that's awesome. But how do we actually use this? Or how can we make an app or a website actually use what data we're providing? Because you can think that we're just providing data if someone knows how to call whatever we provide. Okay? So what I'm going to do is I'm going to create a new project where we're going to create a table that lists out every to-do that we make. So we're going to create a new Xcode project. And we're going to do project. And so for this, we'll just do a single view app. And for this tutorial, I'm going to be using SwiftUIKit and just basic UIKit, not SwiftUI. I I said in my previous stream that I'd probably talk about SwiftUI in this stream, but I've decided that I will put that off until I like to focus on SwiftUI. I'm still more familiar with UIKit, and I would like to give a valuable introduction into SwiftUI instead of just an outdated kind of introduction, because mainly I worked with it when it was in beta and changing a bunch. So we're going to be using Storyboard and Swift. So some table, and I'm just naming it bad. So we can add this. And so the only dependency that we'll need, oh, wait for it to load, is the SwiftUIKit. So I will share that. Oh my goodness, I can't type GitHub. And how we import Swift Package Manager into Xcode 11 or above is File, Swift Packages, Add Package Dependency, and then you'll just add in the URL. So one sec, I'm grabbing that really quick. And we'll just throw in this. I'm going to put it in the YouTube chat too. And I'm just going to use the latest version for that, 1.1.0, but it may change whenever you're watching this. So I would just take the latest version, finish, and you'll see it pop up here, and we're good. Okay. So I can go into this view controller, and I can see everything in here. That's great. Come on, computer. So now if I import SwiftUIKit, that works great. And now I should be able to do view.embed. And let's just put a basic table view. Okay. All right. And now we'll just run that. And this is a newer thing that was added to SwiftUIKit in the latest 1.1 release or version. But I'll be going through an example of table view and how to make a table in SwiftUIKit or UIKit, of course in the back end. But we got this running right now. Alright, I'm waiting for the console to pop up at the bottom to know when it's ready. Near 100% usage. Yep. And so there we go. The console would have popped up, but I already opened it. And you can see that we have a basic table view right here. Okay. So that's great. So how do we actually get the to-dos that we have right here, the title and title notes, how do we get that into our Swift app? So I'm just going to stay in this file. You shouldn't always do that. Feel free to create a file for any object or anything else, but I'm just going to leave them all in here. So we'll just create a struct for the object that we're dealing with, and in this case, it's just to do. And we want to do to be codable so we can convert it and decode it, or decode and encode it into JSON. So what does a to do have? Well, it has an ID, that's an optional int. It has a title, that's a string. And then it has notes, that's an optional string. Okay? Awesome. Well, that's handy. Well, now I think we're done with to-dos. We just need to fetch them. So if we can make this call and get to-dos and something, that would be great. So let's try that really quick. And now I'm going to have to remember how to do. So there's two different ways on how to get data. There's the old way and the new way. And I think I'm gonna choose the old way. Combine is the new way, and I think I'll give a talk on that when I use SwiftUI to give that more cohesive talk instead of, hey, here's UIKit and here's Combine and now you have to use iOS 13. That's the the main caveat of Combine is, or SwiftUI, is that you have to use the latest iOS versions or macOS or anything. So for SwiftUI, we can go back to iOS 9 or iOS 11 or UIKit. Sorry. So we're just gonna create a request. So we want to make a request to here. So we'll do a URL request. And that has a URL. So the URL that we're doing is string. Oops, I just hit the mic, sorry. And we'll just put that. All right. We just need to unwrap this URL, which you can safely unwrap it on your own way, but I'm just going to force unwrap it. For this request, we want to say method is .get, or does it? Oh, okay. I think we need to put get. Okay. So we're just saying that the way we want to. Oh, maybe not. Yeah, it just needs to be a var because we're changing it. Okay. That's good. Cool. So now let's make the task or the URL session shared data task with URLs and completion handler. Okay, so we're doing a URL session shared data task with URL request. Oh, that's a mouthful, but it's not that hard. We already have the request, and now we just need to supply it with a completion handler. So this is after we've made a successful request, what happens? And potentially we'll be passed back data, we'll be passed back a response, or maybe even an error. So on here, we're going to say data, response, and error. Okay. So let's say that we just expect that we're going to get this data, and we don't worry about a response or error. So we're only going to worry about the data for this one. So let's just unwrap the data. Guard let data equals data, else just return. Okay. So now after this, we have the data unwrapped, and we know that we've been provided some data. So let's get a list of to-do objects, and we're going to try to decode them. So we're going to say our JSON decoder. And what are we decoding? What type? Well, simply, it is an array of to-dos. So all we have to say is array to-do self. And from what? Well, the data that we have. Okay. After that, we should be able to print the list. And then simply after that, we just have to do .resume. Okay. So this is going to run. Hopefully we'll get a list of to-dos in the console once this loads up. And yep, that's what I was expecting. We actually don't, and the request itself just fails entirely. And that's simply to the fact that Apple doesn't allow HTTP request or plain text request to be sent. The app transport security policy requires that they must be a secure connection. So we just need HTTPS. If I even said that right, HTTPS. Yes, sorry. But let's search, or I'm going to search HTTP plist Xcode. How about that? Really, we just need to add something to our plist or info.plist that allows us to use HTTP. Normally, you wouldn't want to, and normally any server that you're hosting should be HTTPS, but we want to make sure that it is actually not secure because our local host isn't right here. So if this was S, well, we wouldn't have to worry about this, but yep, sorry. Oh, yep, this is the server. So in here, in the app, we'll go into the info.plist, and we're going to add I think it's it's annoying how they make you add this in. So ns app transport security, or you can type in app transport security settings. But this is a dictionary, and now we can allow arbitrary loads, and we want to say yes. And then we'll add one more thing to this dictionary, and that will be allows or exception domains. And oops, we're going to add localhost as an exception domain for us. So localhost.com, and this will be a dictionary that then, yeah, this is quite annoying. I'm going off of a Stack Overflow article, so I'll make sure to share that, because thank you for whoever who posted this. But yeah, we'll make a new item in here. New. And so this is the Boolean. And then we just want to make sure that we include subdomains. Yep. All right, so now if we rerun it, that's the main annoying part, I'd say. Yep, we get an array of to-dos. So we get the first one, and it says new title. It does not have any notes. And then we have the second one, and it says something here. Awesome. So now we've gotten the data when we want it, and that's right here. Okay. So for simplicity's sakes, let's just update the view, or actually, we don't have to. Sorry. So what we're gonna do now is we're gonna mess around with some SwiftUIKit and create some cells for this table to actually show this data that we have. Okay. So what we want to do first is I'm going to clean this up just a little. I'll make a function called fetch data, and that will just do this. And so after I've done this, I will just fetch the data. Okay, cool. We need the table actually in reference, so we can update the data whenever we want. So if we just save this table view outside, then we can just say table. Okay. Well, table needs some cells to actually show. That's how a UI table view controller or UI table view works. We need some cell to show the data that we have. So for to do, all we're gonna do for if we're using SwiftUIKit and table view, all we have to do for this is to do, and we say cell displayable. Whoops. So we just want to say that, hey, this object or this data that we have is displayable as a cell. So that's all we have to do, and it'll give us an error, and we can just have it fix it. And it says, hey, just give me a cell ID that's a string. So let's say we have some cell that's called to-do cell. Okay. So if we have a to-do cell, then this will work. Let's create that to-do cell. So to-do cell, and that is a UI table view cell. For SwiftUIKit, all I use in here, or all I do in here, is just initialize the views that it uses. So we only have two. I mean, we can make a label for ID, but we really only have a label for title label and notes label. Okay. can't type. Oh. All right, awesome. So we have those. We've created a cell in, very, very basically. It doesn't even know how it's structured or anything. But let's just do extension to do cell, and we'll just say that it is a table view cell, and this comes from SwiftUIKit. And if we say it's a table view cell, then we'll get some a variable that we need to override or to actually conform to, and then also two functions. So for this, we can kind of actually bind this to do with a cell. So now all we have to say is to do cell, have to configure these. Okay. So let's configure it. And you can optionally configure it with the data or not. I guess I will. It doesn't really matter that much because update will update the data always. Configures only run once, and that's to lay out the views. We don't want to lay out the views every time we reinitialize a cell, and cell dequeuing or requeuing or anything like that. It's the main issue for table view cells or table views in iOS. So that's why we'll only run configure once, because we want to just lay out the views if the cell has not been initialized yet. Otherwise, we want to just update the data in that cell. So we'll just say data as data, or data equals data, and since it's cell displayable, we can just convert it as a to-do pretty easily, because a to-do is cell displayable. If the data is not to-do, I don't think we want to do anything. I don't think it should hit here, but we can just return and not really worry about anything. So we're going to say content view dot clear. We want to make sure that we clear everything, and then all we'll do is we'll just embed vertical stack. Okay. And so for this vertical stack, we're going to have title label and notes label. All right. We could populate the data. So optionally, you could do this. You could remove this whole top part because you'll see it's repetitive. But let's do this really quick. So notes dot text equals data dot notes. Awesome. So really, why I say this is so optional is because we'll just copy this and put that right here. Okay. So you can have this. You can have this optionally. This will just initialize the cell with the data, but ideally right after configures ran, update will be ran. Okay. All right. So that's here. One sec. Sorry, trying to show you how many lines we have for. We have a struct with three values in it, or we have this object. We say this object has a cell ID of to-do cell ID, and then we have a to-do cell with some views in it, and then we have a table. We're going to say that we register some cell, and all we're going to do is we're going to register the to-do cell, and we'll just say to-do cell.self. Okay. So now let's just update the data. And all we have to do is say self.table.append, and we're just gonna return the array of the list. Okay. The only thing that we're gonna do different is that we will guard let this list so to make sure that it's not nil and we actually have a value. Okay. But ideally, it would just be better if I combined these two guards and just returned if either of them were false. Because if data's not correct, then, I mean, we can't even get to where we want to be. All right, so the app's going to run. It'll launch the view controller. We'll create a table. We're going to register a cell. We'll embed the table just like this, and then we're going to fetch the data and get an array of to-do objects. after we fetch this, if everything's successful and we do get the array, we're actually going to add that array to the table, and the table should hopefully update with the data and show us to-do cells. Okay? All right, let's cross our fingers. That was a lot of coding and not that much running to see what's happening, but let's run it. All right, it looks like we got the data, and it looks like it potentially hit here, but I'm just going to reload the data, and this might be a main thread issue, but I'm pretty sure that append does not auto reload data, and I'm near positive because now we do get a main thread issue. So simply all we have to do is dispatch queue.main.async, and we're just doing async because we don't want to block the main thread. We want to do it asynchronously, but that definitely does not mean that you can do async main and get away from running stuff on the main thread. You're still on the main thread, and usually the main thread is with UI updates. So that's why that's freaking out, because it's saying, hey, I'm trying to do a UI update, but I'm not on the main thread. And here we go. We let it on the main thread, and now it can update these. All right? So those look cool. Awesome. We added some. Let me add one more. This is a longer title. And I'll just put a lot of blank stuff in and run it. We add it. And now what I'm going to do is first I'll update the label just a little. Let's add these and make these formatted. So body and title 1, just to make them look a little bit different. And they're kind of on the edge, so let's just add some padding to this VStack, and let's say 8. Okay. So we're going to rerun it. We'll see these two, and we should see this extra one that I made. All right, awesome. Oh, and it's truncating a little, so easy enough to do. For the title label, we might just want one line. Oops, typed a little extra there. But for the notes, maybe we want 3 lines. Okay, so number of lines 3, and that's an easy fix right there. All right, awesome. And now we see that extra lines and everything down there. So we've gotten pretty far. We got let's kind of recap where we've gone through this. So we created a very basic Vapor project. It's more of just the template of a Vapor project. We outlined kind of what that entails, what we're using, and a very brief run through of it. We added optional note to ToDo, the ToDo SQLite model, and we are able to run the server and add SwiftUIKit, a framework that I work on and use frequently. And we created a table view, or a UI table view, that fetches data from the internet, or mainly from localhost or my machine, and we fetch all this to-dos. So in under 100 lines of code, we've fetched data and created a table and table view and the data. So that's a lot more reduced than what you'd normally mess with a table view. So let's check out really quick this table view in SwiftUIKit that I made. So this table view takes almost 200 lines of code, but it kind of gives you the option and really takes over the boilerplate. It doesn't do anything for the delegate. You can fully override that, but for the data source, it manages all the items coming in for the data that you pass in. But it reduces it to about here, where we just need to initialize it, we need to register it, we need to add it to a view, and then we just need to add data to it. And that data will automatically be mapped into a cell. We can have multiple cells, and we can have multiple data coming into this table. it's very easily manageable, and you could potentially add in this list or the array that we're passing in right here other data. It doesn't have to be necessarily to do. The reason we can pass all this data in is simply because we just accept cell displayable. Anything that's cell displayable can be the data that's passed in. So this is in here, if you saw, just cell displayable. The data that we have is all cell displayable. So you can pass in multiple different types of data as long as they're all cell displayable, and the table will figure out which cells to show. All right, that's most of the topics that I wanted to discuss on. Were there any questions about what we went over? I would love to go over any more examples if there are any questions or anything like that. But I don't want to drag this on because really I've talked about what I wanted to talk about. So I hope that this was helpful. Again, I'd like to outline that we were using Vapor as the backend, and specifically Vapor 3. And for the front end, we were using UIKit, and we're specifically using SwiftUIKit, which is a framework that I worked on, or I continually work on, or actively work on. So that's all that I got. Again, I hope this was beneficial, but if there's no questions, then I would gladly like to end this. I'll wait a few more minutes for the stream to catch up. All right, awesome. Well, it looks like the stream's caught up. Thank you all for watching. If you had any questions or anything like that, I'm sorry if I missed you. Feel free to post in Discord or comment on this video. We make sure to try to reply to everyone who has a question or a comment. So thank you again for watching. I hope you learned something. See you in the next stream next week.